In December 2020, Dr. Timnit Gebru was on a road trip, taking a much-needed vacation during a global pandemic to visit her mother. Things seemed normal until a colleague texted. An email was making its way through Google's internal networks, announcing that she had resigned from the company. The news came as a shock. Gebru, a star researcher and the technical co-lead of Google's ethical artificial intelligence team, had not resigned. Turns out, she had been fired. In an instant, her access to the company email and servers was cut off. The doors to the institution where she had worked to build a more responsible future for technology were slammed shut. Google's head of AI, Jeff Dean, would later state that the company respected her decision to resign. But for Gebru and thousands of supporters, both inside and outside the company, it was an expulsion. How did one of the world's leading experts on algorithmic bias, a scientist hired to be the company's conscience, find herself on the outside? What was in the research paper that provoked such a severe reaction from one of the most powerful corporations on the planet? This is the story of Timnit Gebru. It is a story about the nature of power in the digital age, the tension between commerce and critique, and the fight for the soul of an industry that is rapidly shaping our world. The way she got fired was impersonal, indirect, and with a story that keeps changing. But this is exactly what she'd spent her career studying. Systems that are hard to figure out, don't take responsibility, and don't care about people. She was not the one to back down without a fight. Timnit Gebru was born in 1983 in Addis Ababa, the capital of Ethiopia, where she was raised in an Eritrean household that valued education. Her father was an electrical engineer with a PhD, but he passed away when she was just 5 years old. This left her in the care of her mother, who was an economist. When Gebru was 15, the Eritrean-Ethiopian War erupted, a conflict that tore families and communities apart. She was forced to flee her home after some of her family members were deported to Eritrea and compelled to fight. This began a harrowing journey to find safety. She was initially denied a visa to the United States and spent a brief period in Ireland before finally being granted political asylum in the US. She would later describe the experience as simply miserable. This was her first intimate encounter with the immense and often arbitrary power of large impersonal systems. The asylum process, with its unseen decision makers and life-altering outcomes, was a kind of high-stakes algorithm governed by rules she could not see or question. It taught her a lesson that would become central to her life's work. A system that claims neutrality can still feel profoundly unjust to those subject to its judgment. This lived experience provided her with a unique lens, a view from somewhere that would later allow her to see what many of her colleagues in technology could not. Upon arriving in the United States, Gebru settled in Somerville, Massachusetts, and attended high school. Here, she encountered a form of prejudice that was new to her. It was not overt hostility, but something more subtle. As she recounted in an interview with The Guardian, one teacher told her, "I've met so many people like you who think that they can just come here from other countries and take the hardest classes." Even though she got great grades in physics, they told her she probably wouldn't be able to handle harder classes. She came to call this the liberal type of racism. People who sound like they really care about you, but they'd be like, "Don't you think it's going to be hard for you?" It took me a while to really figure out what was going on. Her intellect, however, was undeniable. In 2001, she was accepted to Stanford University, the heart of Silicon Valley. She pursued a Bachelor of Science, a Master of Science, and eventually a PhD in electrical engineering. While she was mastering the formal language of circuits and code, she was also learning the unspoken rules of a culture that often excluded people who looked like her. She was asked by white peers if she had gotten into Stanford through an affirmative action program. Later, during her PhD program, she was shocked by the lack of diversity. "There was nobody who looked like me at all," she recalled. Once at a bar in San Francisco, she and a friend, another Black woman, were assaulted. Gebru called the police for help. What happened next was a chilling lesson in systemic failure. She said that instead of investigating the assault, the police accused her of lying and arrested her friend. For Gebru, this was a blatant example of systemic racism. It was a moment where bias and institutional failure became terrifyingly real for her. There was no turning back from this for her. She was beginning to see the bugs in the code of society, an ability that would soon make her one of the most important critics of the code running our digital world. Gebru's early career was marked by a series of roles at the top of the tech industry, including a stint at Apple, where she worked as an audio engineer and developed signal processing algorithms for the first iPad. But it was her doctoral research at Stanford, under the supervision of Dr. Fei Li, that set the stage for her future focus. Gebru was interested in a fundamental question of social science. How do we understand the demographic makeup of our communities? Traditionally, this is done through expensive and labor-intensive methods like the U.S. Census. She wondered if there was a more efficient way, using the vast amount of public data already being collected. Her method was both simple in concept and massive in scale. First, her team gathered 50 million images from Google Street View, covering 200 of the most populated cities in the United States. Next, they trained a deep learning model, a type of AI known as a convolutional neural network, to do one thing: find and identify cars. The system scanned the images and located a total of 22 million vehicles. It then classified each one by its make, model, and year. It was a task that would have taken a single human an estimated 15 years to complete. The AI did it in 2 weeks. The final step was to look for patterns. The model began to make astonishingly accurate deductions by correlating the types of cars found in a specific zip code or voting precinct with public data from the census and election results. If the number of sedans in an area outnumbered the number of pickup trucks, that area had an 88% probability of voting for the Democratic candidate in a presidential election. If pickups were more numerous, there was an 82% chance it would vote Republican. The model could also infer other attributes like income and education levels based on the cars people drove. At the time, Gebru admits, she was focused on the technical achievement. In an interview, she acknowledged that none of those bells went off in my head. That connection of issues of technology with diversity and oppression came later. She had successfully used AI to read the hidden social codes of a society, but she had not yet turned that critical lens back onto the technology itself. That moment would come soon after. The story of the Gender Shades Project began with Joy Buolamwini, a researcher at the MIT Media Lab. Buolamwini discovered that the facial analysis software she was using for a project failed to detect her face. It worked fine on her lighter-skinned colleagues. Out of curiosity, she tried holding a plain white mask up to the camera, and the software detected a face immediately. It was a clear sign that the system was broken in a very specific way. Gebru and Buolamwini teamed up to investigate. Their hypothesis was that commercial facial recognition systems were failing because they had been trained on datasets that were overwhelmingly composed of white male faces. To test this, they needed a better dataset, one that was balanced by gender and skin tone. They meticulously created one, curating 1,270 photographs of members of parliament from 3 African nations and 3 European nations. They classified each face by gender and by skin type using the Fitzpatrick scale, a standard used by dermatologists. With this new, more equitable benchmark, they tested the gender classification services sold by 3 major technology companies, namely Microsoft, IBM, and Face++. The results were not just bad, they were damning. The systems performed almost perfectly on lighter-skinned men, with error rates as low as 0.8%. But for darker-skinned women, the systems failed catastrophically. The error rate for this group soared as high as 34.7%. It was a fundamental failure of the technology, and it exposed a massive blind spot at the heart of the AI industry. It was a shift from asking what technology can do to asking what it should do, and what damage it was already causing. It was this line of questioning that would eventually set her on a collision course with Google. In 2018, Gebru joined Google, taking on the role of co-leading its ethical AI team alongside Margaret Mitchell. She was hesitant at first, having heard from other women about harassment at the company. She wondered how long she could last. Her team was small but diverse, and it took on the difficult work of examining the societal effects of Google's products. They hired the company's first social scientist and raised alarms about everything from bias in Google's algorithms to the weaponization of YouTube by authoritarian regimes to harass dissidents. In 2020, Gebru, Mitchell, and 2 other researchers co-authored a paper that would bring her time at Google to an end. It was titled "On the Dangers of Stochastic Parrots: Can Language Models Be Too Big?" The paper was a direct critique of the technology at the center of a new gold rush in Silicon Valley, large language models, or LLMs. The paper identified 4 main dangers associated with the race to develop increasingly larger models. Firstly, there are significant environmental and financial costs involved, as training these colossal models requires extensive server farms that consume vast amounts of energy and water, resulting in a substantial carbon footprint. Additionally, the financial investment necessary to develop such models is immense, often amounting to millions of dollars. This high barrier to entry tends to restrict access to only a few wealthy corporations, thereby further centralizing power within the tech industry. Secondly, there is the issue of ingrained bias. Since large language models learn from internet data, they inevitably absorb and mirror the biases present in that data. The paper cautioned that these systems risk perpetuating dominant viewpoints, which can reinforce power imbalances and exacerbate inequalities. The third concern revolves around the illusion of understanding. These models are so proficient at generating convincing output that humans tend to trust their results, often falling prey to automation bias, the tendency to believe automated systems are correct even when they are not. This can lead to the dissemination of plausible-sounding yet false information, enabling disinformation campaigns at an unprecedented scale. Lastly, the inscrutability of these models poses a significant challenge. Their complexity renders them opaque, often described as black boxes, meaning even their creators do not fully grasp how they arrive at particular conclusions. This lack of transparency makes it virtually impossible to audit them for biases or hold anyone accountable when harm results from their use. When the paper was submitted for Google's internal review, the response was swift and severe. One of the vice presidents of engineering told Gebru to either retract the paper or remove the names of all Google employees from it. The objections were vague, the paper was described as too negative, and as having handled topics casually. Gebru refused to retract it without a transparent process. She asked for the specific objections and the names of the reviewers who had made the decision. And if the company could not provide that, she wrote, she would begin planning for her departure after ensuring her team was stable. One Google's response was to terminate her employment immediately, stating it had accepted the resignation she insisted she had not offered. The company's official justification that the paper ignored too much relevant research did not align with the view of many academics who saw the work as a solid, if not particularly controversial, summary of known risks. The paper's real transgression was not academic but commercial. It presented a direct challenge to the business model and strategic direction of Google and its competitors. At a time when LLMs were being positioned as the future of search and countless other products, Gebru's paper argued that the technology was costly, biased, deceptive, and unaccountable. Her firing was a clear message to researchers across the industry. You can work on ethics, but you cannot fundamentally question the profit motive. In the wake of her dismissal from Google, Gebru did not retreat. Instead, she began to build. On December 2, 2021, exactly 1 year after she was pushed out of the company, she announced the launch of the Distributed AI Research Institute, or DAIR. DAIR is an attempt to create a new model for conducting tech research free from the fraught incentives of big tech. The institute's structure is a deliberate departure from the Silicon Valley norm. It is distributed, with an interdisciplinary team of researchers, engineers, and activists located around the world, including in Africa, Europe, and North America. This global footprint is central to its mission. The goal is for research to be community-rooted, grounded in the lived experiences of the people most affected by technology. It operates on the principle of nothing about us without us, ensuring that communities are not just subjects of research, but active participants in shaping its direction. The Institute operates independently, free from corporate or government funding that might otherwise jeopardize its integrity. It also explicitly rejects the culture of burnout common in the tech industry, instead prioritizing the well-being of its researchers. DAIR represents a fundamental challenge to the tech industry's definition of progress. It is an effort to build a parallel infrastructure for research, one founded on a different set of values. Since her departure from Google, the world outside of Silicon Valley has recognized the importance of Gebru's work. She has been named one of the world's 50 greatest leaders by Fortune, one of Nature's 10 people who shape science, and one of Time magazine's 100 most influential people. She co-founded Black in AI with Rudie Abebi, an organization that provides community and support for Black researchers in a field where they are severely underrepresented. Timnit Gebru is no longer just a computer scientist. She has become the conscience of her field. In a world rushing headlong into a future shaped by artificial intelligence, her work forces a necessary pause. It is the view shaped by experience, informed by empathy, and anchored by an unshakable commitment to justice.